So let's start with this serially connected resistors. Let's say you have two resistors, load resistance R1 and R2, and I just put these terminals A, B, and C because I should be able to express the voltage drop between the terminals. Anyway, the idea to find the equivalent resistors. But what is the equivalent resistors for this circuit, for example, in terms of R1 and R2? R1 plus R2, that's something you already know. But how do you prove this? You have to prove to me. What you do is, okay, for this kind of circuit, you see you only have one current flowing through the circuit. You have only one branch of the wire. You don't have many branches. So that makes everything easy. If you have one current, if you have one battery, then just use Ohm's law. The relation between the main current and the maximum voltage provided by the battery, epsilon, will determine you the equivalent resistance of the circuit. Well, this relation between epsilon and I is by the Ohm's law. If you express epsilon in terms of I and R, epsilon is equal to I times R, and if you express R in terms of epsilon and I, R is equal to epsilon divided by I, right? So find an R so that you can express this current in terms of epsilon and this R. I made this for you confusing. Sorry. Let's start with epsilon, okay? In the potential at point A, let's epsilon. And the potential drops through first resistance will be I times R1, right? Because the current flowing through the resistor times the resistance. But the potential drop, the potential difference between point A and C, that's something you already know. It is just epsilon. But if you want to express this in terms of the resistances and the current flowing through these resistances, it is just I times R1 plus I times R2. Everything is okay with this. So epsilon, I are related to each other by this equation. But in this equation, you can simply take the I parenthesis, because R1 and R2 are different, but there is a common term, I. So you can write this as I times R1 plus R2. But in Ohm's law, you should always be expressing the epsilon and I with some resistor. And this resistor will be the equivalent resistance of the circuit between the terminals A and C. And you see already that this equivalent resistance is nothing but R1 plus R2. So if you connect the resistors in series, then the equivalent resistance will be the sum of these resistors. If you connect three resistors or n resistors in series, what is the equivalent resistance? Sum of all resistors. Okay, that's it. So let's think about this circuit now. In this circuit, we have two resistors which are parallelly connected to each other, right? We have a common point A and B. This point A is both one terminal of the resistor 1 and it is the same terminal for the resistor R2, right? Because these terminals are connected to each other and there is no any voltage drop along a wire. That's it. So they have the one terminals have the same potential and the other terminals have the other potential VB. And one thing is you should be careful in here. The currents flowing through R1 and R2 are not generally the same because the resistances may not be the same. If the resistances be the same, then you can say that these currents will be the same. And also, you should bear in mind that these currents, I1 and I2, is not equal to the main current on the circuit. The main current, the current flowing through the battery. The current flowing through the battery is the main current in the circuit, but in some circuits, this current may be branching out at some points, right? For example, here. The main rule is whenever there is an incoming current to a joint point, the outgoing currents, the sum of the outgoing currents will be equal to the sum of the incoming current. So you can easily say that here I, the main current, is equal to I1 plus I2. So with this in mind, let's calculate the potential drop between the terminals of the first resistance, R1. It is I1 times R1. It is not I times R1, but it is I1 times R1. Because the main current is not equal to the current flowing through R1. So the voltage drop between the terminals of R1 is I1 times R1. What about the voltage drop between the terminals of R2? I2 times R2. But, well, what is the relation between this V1 and V2? Why? Because their terminals are the same. The terminals of R1 and R2 are the same. If you are talking about the potential difference between the terminals, since they have the same terminals, their drop must be the same. So I1 R1 must be equal to I2 R2. V1 is equal to V2, but what is V1 and V2? It is nothing but epsilon. Because the terminal of the current, the resistances, is also the same terminals for the battery. So from this, you should be able to write down a relation between the epsilon, the current, main current, and the potential difference from this. And we know also we have to use this expression because I1 plus I2 is equal to I. And I should be able to find the relation between the main current, the main provider, the battery, and I will find the resistor quantity R, and this resistor quantity will be the equivalent resistance of these two parallelly connected resistors. Let's do this. I know that I, the main current in the main branch, is nothing but I1 plus I2, but these are epsilon in terms of epsilon, the battery, epsilon divided by R1 and epsilon divided by R2, because this is equal to epsilon, and this is equal to epsilon. From this, then I can write down this I1 and I2 in terms of epsilon and R1 and R2. So there is a common term in here, which is epsilon. I can take the parenthesis of epsilon. Epsilon times inverse R1, inverse plus inverse R2. And you see, there is always this relation between the main current, the epsilon, and the equivalent resistance of the circuit. The equivalent resistance of the circuit is always will come as the denominator on this side, and this 1 over R equivalent must be equal to 1 over R1 plus 1 over R2, right? So you see, I am already expressed the equivalent resistance of this circuit in terms of the resistances R1 and R2, but it's not equal to, it's not like R equivalent is equal to R1 plus R2, but it's inverse. The inverse 1 over R equivalent is equal to inverse R1 plus inverse R2. So finding the equivalent resistance is different in the parallel connection circuits, and it is not simply R1 plus R2, but 1 over R1 plus 1 over R2 is equal to 1 over R equivalent. All right, so these are just the proofs, okay? And you don't need to worry about these things when you're solving the problems. All right, if you have n number of resistances which are parallelly connected, then the equivalent resistance, 1 over R equivalent, is equal to 1 over R1 plus 1 over R2 plus 1 over R2 plus dot, 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 whatever the number of resistors is you had to add as inverse to this equation. All right.